Now we are going to talk about constants. Constants are values that are never going to change, or hardly ever, and we give them a special treatment in C++. They have the const keyword. We put the name in all caps. It's also going to work if you don't do it in all caps, but it helps to set it apart for anybody else that has to work with the code. And the value has to be on the same line. Now, the thing is, by using the const keyword, you cannot change this value during the execution of the program, and we'll see that in another program too. Now, you really only want to use constants for values that never change. Examples that I tend to use are the days in the week, the numbers of states in the union, the number pi, and a thing that we also frequently use as a constant is something like a sales tax percentage, because they hardly ever change. By default, we always put the constants all the way at the top, which makes them easy to find and easy to modify if the program ever has to be changed, for instance, because the sales tax has been adjusted. Okay, the other thing that we use it a lot for is the size of arrays, and that's supposed not to be changing either. You'll see that in later programs too. Now, this book uses constants way too much, and I'm going to change them to variables whenever that's more appropriate. Just to show you the benefit of using constants, I have over here the number pi, and that's used to calculate both the circumference of a circle and the area that is covered by a circle. And you know that the number pi can be specified at different levels of precision. So let's see how that works. Over here I have defined pi with the const keyword. I always have to include the data type. The name is always in all caps, and over here I have the value immediately specified. Notice that when I highlight pi over here, you see that over here it's used in the calculation of the circumference with the diameter. Over here we use it in calculation of the circumference using the radius, and over here we do it to calculate the area that's covered by the circle. So when I run this, you see that I get these numbers over here. These are exactly the same, of course, because it's the same calculation with different means.